Here's another example on how to identify the interval of increasing, decreasing, and constant. This time we're going to have to use a graphing calculator. In this example, we're giving a function f of x equals negative x to the third plus 6x squared minus 9x plus 5. And we're asked to use the graphing calculator to help us find the interval of increasing, decreasing, and constant. It tells us to adjust our window view to x to negative 3, 7, and negative 30, 30. This means the x min is negative 3, and the x max is 7, y min is negative 30, and y max is 30. First, we're going to go on to the graphing calculator and go to y equals, and then enter the functions on here. So we have a negative x cubed. Be sure to use the negative button and not the minus button. There is a big difference between those two. If you use the minus button, it's going to give you an error. So make sure, again, use the negative button that's within the parentheses next to the enter button. Negative x cubed plus 6x squared minus 9x plus 5. Then we go over to where it says window, and then we'll adjust the windows. Negative 3. And again, you have to put in the negative on the left side of the button that says enter and not the minus button, okay? The x max is 7. Y min is negative 30. Y max is 30. And now let's press the graph button and we see the graph. Notice that this graph is a little bit stretched out sideways, but it is the same graph here. All right, so next let's identify increasing. On this graph, we can actually see where it increases. It increases right here to here, but we don't know where the x values, what the x values are at these points. So in order to find where the x values are, what we do on the graphing calculator is we're going to, now notice this right here, it's a min at this location. That's because it's the smallest point in this area right here. On the graphing calculator, we go on second, click on second, and then calc. That's where the trace button is at. And then go to where it says minimum. Then what you're going to do is it's going to ask you for the left bound. So you're going to go on the left side of the minimum. Press enter, and then go to the right side of the minimum. And then press enter. Your calculator will ask you to press the enter one more time. So enter, enter, and then you will see the minimum. That this point is at negative 1. Sorry, not negative 1, but positive 1, comma 1. Now we're going to do it again to find the location of this point, but this time this point is a maximum just because it's the highest point around there. So we're going to go to second, trace, then go down to where it says maximum. And again, we're going to go to the left side of the maximum, which it's already there. Press enter, and then go to the right side of the maximum. Press enter, and then press enter one more time, and it will give you the point, the location at that point at 3, 5. So now that we have the location of those points, we can now identify the interval of increasing. So for increasing, the x where it starts is at x equals 1. The x where it ends is at x equals 3. Decreasing. Okay, highlight where it decreases. The x value where it starts to decrease is negative infinity. The x value where it stops to decrease is at x equals 1. And then it also decreases. The function also decreases right here. So we have another interval. The starting x value where it starts to decrease is at 3, and the x value where it stops decreasing, it's infinity. It doesn't stop. For the interval of constants, there's nowhere on this graph where the graph is not moving up or down. Where the graph stays constant, where it doesn't move up or down. So for constant, there is no interval, we say DNA.